So where we finished yesterday is with, or not yesterday, the day before, is this with this here, talking about angle properties of other polygons. Now we went on and identified each one of these shapes. This here was our square, rhombus, rectangle, trapezoid, and Now, the next part of the lesson is asking us, what is the sum of the interior angles of each one of these shapes? Well, we know a square has 4 right angles, and 4 right angles will add together to be what? 360. Well, it works out that all of these are going to be 360, because the sum of the interior angles for any polygon is 360. Guys, let's go on and put the Chromebooks and computers away. Thank you. And really what this is going over, well, rule for any quadrilateral, is the sum of any quadrilateral is 360. This is going over our n minus 2 times 180. The sum of the interior angles for any polygon is defined in this way here, n minus 2 times 180, where n is the number of sides. For a quadrilateral, that'd be 4 minus 2 times 180. Well, 4 minus 2 is 2. And 2 times 180 is 360 degrees. So any 4-sided figure is going to have the sum of the interior angles as 360. So whenever we look at any of these figures here, the sum of their interior angles is 360. And for these figures here, especially for the first two here, these are parallelograms. And the properties that we do have for parallelograms is that the opposite angles are going to be the same. So this angle up here is 83 degrees. And the consecutive angles add together to be 180. So we can say 180 minus 83, which would give us this would be 97, which means this angle down here is 97. And if we added all 4 of these together, we would get 360, because the sum of the interior angles of any 4-sided figure is 360. And we also know that because this here is a rhombus. Now this one here is again a parallelogram, so the opposite angles are going to be congruent. And the sum of the consecutive interior angles is 180. So we can take 180 and subtract 124 from it. So the other two angles are both going to be 56 degrees. Any questions on this so far? Now the last one's a trapezoid, and it's not isosceles, so that tells us that the base angles are not going to be congruent. If it's isosceles, then these two angles here and these two angles here would be congruent. They'd be the same. But we know it's not isosceles because the two sides, one of them is 3 and the other is 4. But what we do know is that the consecutive angles, these here, are going to be supplementary. They're going to add together to be 180. So for the left-hand side, well, we can take 180 and subtract 117 from it. And on the other side, we can take 180 and subtract 48 from it. and exactly get 132 degrees. So this angle up here is 132 degrees. But again, all four of them will add together to be 360. So our rhombus, and exactly, we got this here, 83, 83, 97, and 97. Our parallelogram. So we get that this is 124, and exactly as we found, 56 and 56. And 32 and 63. Any questions on any of this here? What do all the angles have in common on the same line? They had together to be 180. Straight line's 180. Straight line's always going to be 180. So this here is again going over our properties of diagonals and congruence. So which of these diagonals must be congruent? Whenever we talk about a rectangle or square, rectangle and squares have congruent diagonals. Which ones may the diagonals be congruent? Rectangles, squares, or trapezoids. The trapezoids will be true if it is isosceles. If it's an isosceles trapezoid, then the diagonals are congruent. Which shapes must they bisect? Well, any parallelogram, rectangle, square, rhombus, and parallelogram, all of these, they will bisect each other. They'll cut each other in half. Which one will they never bisect? Is trapezoid. In which shapes must the diagonals be perpendicular to each other? And that is going to be a square. Huh? Because a parallelogram is a four-sided figure with two sets of parallel lines. The interior angles of a triangle add up to 180, while the interior angles of a quadrilateral add up to be 360. And again, these are things we've already covered and we know. Each time a side is added to the shape, the sum of the interior angles is increased by 180. Or n minus 2 times 180. That's all it's saying. That is what that formula is, because each time we add a side, it's increasing the sum of the interior angles by 180 degrees. And we use the minus 2 because a three-sided figure, a triangle, is exactly 180. So we're offsetting that. Some interior angles of a six-sided figure or hexagon. We'd say 6 minus 2 times 180, which would be 4 times 180, which is 720. Interior angles of an equilateral triangle are each, well, the 60. Interior angles of a square are each what? 90, because they're all right angles. Interior angles of an equilateral pentagon. So pentagon is 5 sides, yes? 6 is 720, so 5 has to be And if they're all the same, we can divide 540 by and get 108, because one angle in a regular polygon is defined by the formula n minus 2 times 180 divided by n. N minus 2 times 180 is the sum of the angles. We can divide it by how many we have, n, and get each one. And we can do the same thing for a hexagon. So we take 720 and divide it by 6 to get that each one of the angles is 120. Questions on this here? Okay. We're going to finish there. So I'm not going to make y'all do the entire class time. Be a little bit nice to you guys the week back. So you do have the exit tickets, which will be these 3 questions here. This will be the first one. Go on, answer those, get those done, and then you are done for today. As long as you finish both the entrance ticket and exit ticket, you're finished with all of this.